Alright, in this example, I'm going back to the two vectors I gave you in a previous example. Vector v is 2, negative 3, vector w is negative 1, 4. And we know this cosine formula now that gives us the angle between the two vectors, the smallest angle between the two vectors. And remember, theta must be the smallest angle, not the larger of the two angles. Okay, here, so I'm trying to find then the smallest angle theta between v and w. That's my goal, and I'm going to use this formula to do that. So all I need to do is calculate the dot product, v dot w, to start. So v dot w, remember, is the product of the corresponding components added together. So it'd be 2 times negative 1, and we did this in another example, but I'll run through it again, plus negative 3 times 4, which is negative 2 minus 12, which is negative 14. Okay? Then I need to calculate each of these magnitudes. So the magnitude of v, we also calculated in a previous video, is square root of 4 plus 9, which is the square root of 13. And the magnitude of w is the square root of, let's see, 1 squared plus 4 squared. That's 1 and 16 added up is 17, so it's a square root of 17. Okay? So I've run through those before, but those are the two values you would get. And so from here, we plug that stuff in so that the cosine of theta is equal to the dot product, negative 14, over the product of the two roots. So that'd be root 13 times root 17. We could put those roots together because they're multiplied. 13 times 17 is 221. So it's the same as saying negative 14 over the square root of 221. Okay? So now to find the angle theta, I'm going to use the inverse cosine, right? So theta, now we'll move it over here. Theta equals the inverse cosine of that quantity, negative 14, over the square root of 221. I'm not worried about rationalizing the denominator here because I'm not using that as a final answer, and I'm not doing anything with it algebraically other than just plugging it into this cosine, inverse cosine. So that's what we're going to do. Just go inverse cosine of negative 14 divided by the square root of 221. And that gives us about 160.3 degree angle if I round that to the nearest tenth. So this is approximately 160.3 degrees. That is a second quadrant angle. It's an obtuse angle. And so that comes directly out of the cosine, out of the inverse cosine. I don't actually need to worry about trying to convert this or anything like that. The nice thing about the inverse cosine is it will do that for you in this type of problem. So that's a direct output. We don't have to worry about anything, any weird conversions or anything like that. So that tells us there's a 160 degree angle roughly between these two vectors. And that's the smallest angle between them.